don't forget to subscribe before watching this video, okay? I said don't forget to subscribe before watching this video. I have a problem with me here on what machine, okay? It is very simple, very simple, but there are some techniques that one can use in approaching this kind of what problem. So let me quickly run down the problem on the board. A plane inclined at an angle of 30 degrees to the horizontal has an efficiency of 60 degrees. The force parallel to the plane required to push a load of 120 Newton uniformly up the plane is what? So they are asking us to look for the force that is parallel to the plane that will require to push the load downward. What is that force? That force is the what? Effort. Okay, so let's proceed. Solution to this problem. Like I said, don't forget to subscribe as you are watching this video. The first thing I need to do is that I'll bring out the parameters from this problem. Okay, so a plane inclined at an angle 30 degrees, means my theta is what? 30 degrees. To the horizontal has an efficiency of 60%. So my efficiency is what? 60%. The force parallel to the plane required to push a load of 120. So my load is what? 120 Newton. Uniformly up the plane is, what is that force I'm looking for? Is effort. My effort is what? Unknown. So if you check, this problem is on classification of machine. So strictly on what? An inclined what? Machine. Am I communicating? Inclined what? Machine. When you have something like this, you have something of this kind, you have something like this, you have this, okay? So this is the effort we're looking for, and this is the frictional force, this is the load, that is being given, okay? So this is the angle theta. So from this diagram, okay, this is the frictional force, this is the effort required to push this load upward, like they said in the question, and this is my load that is being given, and this is my reaction force, R. So from this, my velocity ratio is what? 1 over sine theta. Okay, so my velocity ratio is equal to 1 over sine 30. My velocity ratio is equal to 1 over 0.5. Okay, my calculator, because sine 30, let me confirm, sine 30 is 0.5. So 1 divided by my answer, I have my 2. So my velocity ratio is 2. Okay, as you can see, my velocity ratio don't have my XI units. It has no units. Okay, the next thing I'm going to look for is my effort, right, which is my efficiency is equals to mechanical advantage over velocity ratio times 100%. Okay, times what? My 100%. My efficiency is given as 60 over 100 is equals to my mechanical advantage is not given. My velocity ratio is what? 2 times what? 100 over what? 100. Okay, so this will go, this will go, this will go, this will go. 6 divided by 10, I have my 0.6 is equals to m.a, mechanical advantage over what? 2. Okay, so the next thing I need to do is that I'll cross multiply this times this. My mechanical advantage is equals to 0.6 times what? 2. So my mechanical advantage is equals to 0.6 times what? 0.6 times 2. I have my 1.2. So and this is my mechanical advantage, which I have solved. In my mechanical advantage also don't have what? SI what? Unit. So the next thing I'll need to do is that I will need to look for my effort now. My mechanical advantage is equals to my load over my what? Effort. Remember, my load is given and my mechanical advantage has been solved. So I'll need to just cross multiply. I'll cross multiply. Okay, I'll cross multiply this times this. I have my mechanical advantage times my effort is equal to what? My load. If I decide by coefficient of what? My what? Effort, which is MA, which is MA. So MA will cancel MA. My E is equal to what? Load over what? Mechanical advantage, which is my E is equal to my load is what? 120. And my mechanical advantage is 1.2. So 120 divided by 1.2. I have my 100. So my effort is what? 100 Newton. Okay? So that's all about the problem on the board. Don't forget to subscribe after watching this video. Thanks.